Hi, my name is Tom Murphy. I'm the Chief Marketing Officer for Turbonomic, and welcome to the Apps on Cloud Summit. Today, applications of the business, and today's business has definitely gone digital, in many cases faster than we anticipated. Virtually every company is going through some form of transformation, whether it's replatforming, re-architecting the apps, but they all still need to be resourced to ensure the performance, compliance, and minimal costs to deliver those resources. Over the next 3 days, we'll talk to evangelists, visionaries, industry analysts, and even practitioners, yes, practitioners who will keep us honest and where the rubber meets the road. So we have 4 tracks to look at. One is the C-level track we refer to as main stage. The second is apps on public cloud. The third is apps on containers. Really, think of it as a DevOps track. Optimizing network performance is the last track. Think of it as if apps don't have the resources they need, compute, storage, and network, the applications are not going to perform. The one thing I wanted to reassure you is all these sessions are being recorded and can be replayed after the event. So if you have 2 sessions you want to see at the same time, by all means, go back and look at that session after the event. As we kick off, let's get ready to get educated, inspired, and ultimately activated to go take action. On behalf of Turbonomic and our co-sponsor AWS, I want to say thank you for attending. I'm delighted to kick off the event with 2 gentlemen who know very much a lot about apps and performance. My 2 friends, Mirko and Ben. Take it away, gentlemen.
So welcome, Ben. I'm super excited because you're kind of a legend in our space, and I'm happy to be talking to you here on this webinar series. How are you today?
I'm doing well, Mirko. I'm actually envious of that tan. I don't know where you've been, but it sounds wonderful, and it's good to see. But thank you for that intro, and I'm super excited to be here with you. So thank you.
Thank you. So Ben, you are CEO of Turbonomics, but before that, you have been on the venture capital side, and I read that you have been a 6-time member of the Midas list, which is like the list with the most successful investors. And I also know that you have invested in this space. I think you were an investor in Dynatrace. And so you know this space pretty well. And so I would love to get your view as an investor, but now also as a CEO. How has this space of observability monitoring changed in the past decade, I would say?
Well, thank you. So actually, there are a number of, so one was Dynatrace, another was called Tracelytics, which is SolarWinds API. The early and first one, even before Wiley, was one called Precise Software. So lots and lots in this space. The most significant difference is that people have now figured out how to actually make the installation in terms of bytecode instrumentation, delivering the topology of the app and response time measures much more straightforward. And I think Instana is a great example of that, just the facility with which one can get up and running, particularly in cloud native, which, as you know, is much more difficult. What I think they've come to realize, though, in the customer side, is the importance of making sure that the applications are also not starved of resources, right? And so one of the things that's changed enormously from literally 1999, when we did our first distributed APM company, was the ability to redefine everything in the form of software. So the software-defined data center, and allowing the access to all of that compute, storage, networking through software, through APIs, meant you could make it self-actioning. So you could take something from observing all the way through to literally automating. And so the role and the opportunity for AI, artificial intelligence, to help assure the application's performance, maintain its policies and compliance with how they want to run the app, and at the same time deliver a much more cost-effective experience. That's where the two came together and really afforded us, and more importantly, a ton of customers, the benefit of running Instana with ARM, application resource management, which is the fit that we're talking about here.
Yeah, that's great. So I can just imagine if you had been a successful investor and then you made the decision to basically go on the other side, right, and become the CEO of Turbonomic, which is application resource management. What made you excited so much that you made that decision, and why do you think is ARM so successful, and why is Turbonomic so successful today?
So I've had a lot of interest. I was actually the chief operating officer at Precise, that first generation distributed APM. Became an investor and focused very much on the management tools space, and that was an important one because one of the benefits was, just like you, coming with the benefit of an application-centric view. Okay, so everything I invested in that, broadly in that space, was all about always helping improve the performance of applications, because applications are the business. What got me so excited about Turbonomic that I decided to step down as co-managing partner at Bain Capital Ventures and instead run Turbonomic was the ability to actually now take it one step further and deliver performance assurance. And that was just captivating. So no more thresholds and alerts. I mean, the world is over alerted, right? What we really want to do is we want to be able to make these applications pick the resources on which they want to run to assure their own performance. Why? If the application today, Mirko, is the business, and the business is the application, right? The modern application era. Why would we want to ever let that application fail or violate an SLO when it doesn't need to, right? The secret, though, is we had to change the underpinnings, the way those applications are resourced. And if we could do that and prove that we were right by validating it with the response time on the application through Instana, then you had a win-win for the customer that frankly was a game changer. And so what Turbonomic did was to take all of the resources. You can't have everyone with their own fragmented tooling any longer. You know, the network guy with a network tool, storage guy with a storage tool. Take all of the resources on which the application performance depends, and then serve them up in a marketplace where when an application, the demand goes up, they get more budget, they can go preempt resources. When their demand goes back down, they give back budget and they seed resources. And that's how you can solve something in computer science called the sharing problem, that without that, resources congest and it starves the application from performance. And you see that loading, spinning wheel of death, right? Which is brutal to the business's brand or to their return on innovation, and frankly treats their customers poorly. So eliminating that was really the key here, and what was so exciting.
Yeah, and so as far as I know, when I looked at, I mean, I followed Turbonomic for the past decade probably. When you started as a CEO, it was a lot around infrastructure, right? Infrastructure and managing the infrastructure resources, also from an infrastructure perspective. So what I mean by that is you looked at servers and CPUs and VMs, right? And in the past years, I have followed, and I know because we were partners and Instana and Turbonomic work together. I've seen you transition more to an application view, so going up that stack and managing the resources more from an application point of view. Which, I mean, as an application guy, makes total sense to me. But can you explain a little bit how you came to that conclusion that you have to go up that stack and move towards an application view instead of looking just at the resources?
Sure. The whole idea from the beginning was to always get to the application. It just took us some time. But the reason was, again, why do we care about whether a virtual machine is either scaled too big or too small or in the wrong place and needs to be moved and all those kinds of things? We will be able to execute those actions, but only if they're in favor of the application performance, right? But to get all the way up to the application, remember, there were so many different tiers, right? So just think about a typical environment. You got your physical, compute, storage, and network. Now you've got the virtual tier. You got to think about how to optimize that. Then I probably have containers and pods and a scheduler. And then I've got the APM at the top. And the joke, it's pretty bad humor, but the joke they say is the more tiers you have, the more tiers you'll have, because the performance on the application at the top is so removed from the resourcing decisions all the way down through the stack. So the idea was you can't really build this top down. You have to build it going bottom up, right? The ability to automate decisioning started with virtualization, then moved to cloud, then moved to containers and microservices, right? And it was the ability to unify that. And we're the only solution that unifies the full, what we call application stack. But now you're looking at all of the resources on which the performance of the application depends. You're making them dynamic to support the dynamic demand, no more static resourcing. And that's how you can assure performance. But it was always the goal to get up there. The reality is you've got all of these different market share vendors that you had to be able to ingest their technology, right? So the physical, the logical resourcing tiers, you had to be able to ingest their capabilities, normalize it, and make it available for the applications to choose, all in a common data model. And that's how the AI works. So the good news is there's no agents. You can drop this in. It will build a supply chain view of everybody's applications with what we call stitching from the application all the way down through every resource tier. And then it'll show you explicitly, where do you have congestion? Where do you have compliance violations? And lastly, where are you over provisioned? Because actually the way you pay for this is by not having to over provision your public cloud environments or your private cloud environments the way people did in the past. That was always deemed an allocation model, and people would over allocate to try and assure some form of safety. But the reality is, if you're coming top down from the application lens, you've actually built something very interesting. It's a consumption model instead of an allocation. Allocation is a fancy word for guess, right? People are going to allocate some kind of number of resources. But consumption, you can know exactly how much resources, you can know exactly the order for exactly the point in time. And that's how consumption works. That's how markets work. And so that's what we've really built. But the only way to know that you're making a good, trustworthy resource decision is with the application context, hence the partnership between Instana and ARM, because we can validate every one of those resourcing decisions by showing an improvement or certainly no degradation in the application response time, which is what the business cares so much about.
Yeah, before I go, we have one question here. Before I go to that question and talk about the acquisition with IBM and how this all fits together, I have one question for you that I found always interesting as an APM guy. What is an application for you? And how has that definition changed also for your customers? Because we always talk about applications, but I think it's very interesting that if you ask 20 people, you get 20 different answers, right? So and I know that I really like the model and the way Turbonomic has defined the application and the context. So how did you come up with this, or your team?
Well, there are lots of ways to define. Short answer is there's a business application, and then there are a series of services, and then business transactions. So you can take it all the way down to whether you want to look at the performance and response time and SLO violation or adherence of any one of those. You can look at the aggregate business application, or you can take it down into those different tiers, meaning the services and the transactions, or even, by the way, down to the application components. Like, am I stringing together a bunch of JVMs or whatever, right? But that's on the technical answer. Then the next one is, it's really something that the customer defines as a business service, right? So let's think of a simple application. You have an end user accessing a web server, the web server accessing an app server to a database, to storage, whatever. There's a 4-tier app, right? There's your topology. Now, every one of those hops has resourcing dependencies underneath it, the logical and the physical resources, containers, pods, virtual compute storage and network. And if any of those resources in any one of those stacks under any one of those hops congest, whatever that customer's business service, it doesn't happen, or it slows. And if that's an e-commerce app, then the checkout process could, load the shopping cart or whatever, could absolutely kill the performance that an end user, a customer, receives. And that's anathema to a healthy business. So what we're doing is we're saying, okay, we're going to take the customer's definition of an application. That can come in the form of, obviously, the APM instrumentation, bytecode instrumentation, which provides that topology and provides that response time. If they don't have it, then customers in many of the environments can tag individual VMs or JVMs into, like, let's say through vCenter or whatever, and can define an application topology and provide a response time through something like a Prometheus or other open source products as well. They're nowhere nearly as involved for a developer, but they can do the production response time analysis on a properly defined application through the lens of a customer's definition. Did I answer that question okay?
Absolutely. I totally agree. That was one of the things when we came up with our application definition at Instana, which we call an application perspective. It was exactly what you said. We wanted to give the customer the chance to define their business application in the way they defined it, right? Because as you know, if you look back at tools like Precise, Wiley, at that time, applications were pretty simply structured, right? You maybe had an application server and a database, and the mapping between an application was pretty much a one-to-one mapping to an application server or something. This has totally changed in the past years, because now you have hundreds or thousands of services, and the application has more become a virtual thing, right? Something that you define from a business perspective, and then it maps to 100 services, which again map to resources, servers, VMs, etc. And so I think you can't anymore do a one-to-one mapping between an application and infrastructure. It has to be a more dynamic way of doing so.
Yeah, actually, just to play on some fun, a little history. If you go back to the days of Precise, the volume of applications were so much fewer, and the number of hops in an application topology were so much less. We would actually use timestamp, the timestamp correlation in the IP header in order to know this logically inferred, call this one, and so on. The big change is obviously today that would never work, right? A typical microservices app, if you look at Gartner, will have over 500 components to it. And then on top of that, with the interface with the CI/CD, they could be changing any one of those components in a daily basis. So there's just no way for a customer to stay at pace with that and assure performance, right? And so then when you think about that, all the different stakeholders, the number of times they iterate on changing a componentry of an app, and then all the resourcing that has to come along with it or it won't perform, this is just a bit of chaos, right? So our whole purpose is to say these issues have long since surpassed the complexity, the scope, the scale, what humans should do. They need capabilities like AI to help make this work. And then think about an app that runs both on-prem and off, like a composite app running on-prem and in the cloud. Like there's a Fortune 500 customer of ours that has an e-commerce app that runs in both. And they've wildly over-provisioned, and yet they're still getting poor response time. Well, it turns out in their Azure instance, they had undersubscribed the storage tier. So the volume was congesting the whole thing. So right when they're getting the best audience and throughput on their application, they're giving them the worst experience because it's congesting and the response time is undulating and slow. And only by seeing all the way down into that, what we call supply chain view, all interrelated, and understanding where the root cause is, which is what we do. That's why we came bottom up in our evolution as a company. Now you can easily solve that. You just reallocate storage. You just, change the size up, which was non-disruptive in Azure. It's one of the best features, but you needed to see it to understand it. And heretofore, the storage person was totally separate from the compute person, who was totally separate from the network virtual and all these different people. So bringing it all into one in order to assure the performance of that application and then validate it with the APM product, right? That's the holy grail.
Absolutely. So we have a question here, which I think is interesting, and I did not forget the second question, and that is, Jonathan asks, he said he gets the application view, but he says 99% I'm working with the hardware, right? Which I get, because especially in the cloud, you buy EC2 instance, whatever, and you pay for it, right? Is there a way in Instana, and I will take the same question for you and for Turbonomic, to dig down to the level easily? So how to get from the application level to the hardware level? And I can answer that for Instana. I think it's very similar to hopefully very similar to your answer, but In Instana, we have something we call the dynamic graph. So we basically have a topology, a dependency view, and we understand, Ben, as you said, we say there's an application and it uses these 10 services. And then we also map those services down to the infrastructure. So we would know these are 10 Java services. So they are running on these 10 JVMs. These JVMs are running on this virtual machine on top of this hardware or cloud infrastructure. So we have the mapping, and we call it the context that we provide. So if we go on an application, we can show immediately which servers are involved, which containers, which JVMs. So people can actually come from the application view pretty quickly down to the infrastructure view and see resource contention, etc. And I would assume, because you are automating that, and you are taking the information of context and application from tools like Instana, that you have the same mapping or even a more dense mapping because you have to automate. Is that correct, man?
Yeah, it all comes down to, can you get to root cause, right? So by the time you're down to literally storage in the example you used, think about where you need to be able to trace up, right? So let's go with, for example, the value, fundamental value of a consumption model. If demand increases and I know how much it increases, then I can actually size how much resources more it needs. Then I can look in each successive tier. So let's say your example, let's say, okay, we've over provisioned the heap in a JVM. Great, too much memory. But that in turn puts pressure on the VM. So now I had to over allocate my virtual memory, my VMem in the JVM. Now, where does that JVM run on a host? But here's the problem. If I over allocated at the top level and the next level, then I got to over allocate at the physical level. Well, this is getting very expensive, right? And then what do people do when they go into, into the public cloud? Whatever instance of compute they guess at or allocate, they then also allocate tier 1 storage. Well, storage is 6 times the size on average of a virtual environment, the number of instances in virtual. Public cloud makes a huge amount of money. But by coming down through the consumption of the application, we actually go through the compute and see the needed IOPS. How much input output do you need from storage? So instead of allocating tier 1 storage, let's give you the exact amount you need times all 6 volumes for 1 compute. And here's the best part. Changing storage, non-disruptive. So think about how straightforward this is. I can immediately give you 3 times the ROI because I can put you in exact versus the top tier storage, because I can put you in the exact IOPS that you need because I see it through the consumption lens, starting at the application all the way down. On top of that, we can then clean up the environment by not over allocating the heap in the JVM, by not over allocating the VMem in the vCPU in the V virtual machine, by not then congesting the physical host and not killing the IOPS. In other words, the whole stack can run smoothly. The reason people have done this over time is they were always coming at it from an allocation principle. And again, allocation means guess. How do you know what demand is? I don't know. I better put something out there because it has to run. And if I guess low, guess what? I have to go again right away because the application won't run. So everything is over allocated. That's very expensive on-prem, but it's crazy expensive in the public cloud where I pay for that over allocation every second, every minute for the rest of time. So all of this is about, how do I get the right balance? How do I assure the performance of the application? How do I respect the policies that the customer wants? And then I can save you money safely. But if I just promise to save you money on your cloud bill, no one has a cloud bill that they like, but they don't cut it because they're worried about performance. So the biggest difference here is our AI will allow the customer to safely save the money by assuring the performance of the application first and validating it with Instana, then checking the policies and adhering to them, and then say, okay, take these actions.
I totally appreciate about this conversation is you really made clear the difference between allocation and consumption, right? And though it was kind of clear, I never thought about this in a way you described it, and it makes total sense, right? We are normally in an allocation-based world, right? We learn to allocate things, and I still think t-shirt sizes are still there, right? Look at the EC2 sizes, right? It's S, M, L, XL. So you still buy t-shirt sizes in hardware, but I totally agree. It should be the other way around, right? You should pay consumption based, and you should automatically only consume what you need, right? So that's really, that's basically what I said, right? From a business perspective, I want to basically only allocate what I really need, right? And so what I consume, right? So
right. If the supply side system worked and allocations worked in a market context, the former Soviet Union would still exist, wouldn't it?
Yeah.
But the rest of the West, right? They decided, no, let's go on consumption. Let's use markets. And guess what? It's worked enormously well. So there's your proof point, right? But I think now let's make the consumers the applications, and the changes in application demand up and down afford you more or fewer resources so you can share those common resource, logical and physical tiers dynamically.
Yeah. That was a great learning. I totally agree. And it will give me some time to think about it more. But I like it.
Think of the word allocation as guess. That's all they're doing. They're guessing. Sometimes they guess better, sometimes they guess less well, but a guess can never be as exact as consumption.
Yeah, absolutely. Thanks for being here. And thanks everyone for asking the questions.
And congratulations to you on your combination with IBM. I wish you all the best on that. We'll be your partner.
Thank you. Thanks, Ben. Thanks, everyone. Have a great day. Thank you.